Same worksheet? Okay. This is the integral of tangent 5x secant squared x dx. All right, I'm going to rewrite first, guys. So that's tangent x 5 secant x squared dx. All right. So question, what's my u here? Okay, so I'm going to make u equal to tangent x. That means the derivative is equal to secant squared x times 1, right? The derivative of x is 1. So dx is equal to du over secant squared x. All right, I'm going to replace two things. I'm going to replace my tangent x and my dx. So what I do is I rewrite everything except for what I've circled. When I circled it, then I'm actually going to replace it with either u or my dx right there, okay? So then what I get here is I say, do my x's cancel out? Does secant squared, wait, that's not a 5, sorry. I think that should be a 2. Okay, does secant x squared cancel out with secant squared x? Are they actually the same? Real algebra, not the fake stuff. Okay, so that's 1. So what scalar can I pull out of here? I don't think there's any scalar. So that's u6 over 6 plus c, and that is a great answer. Okay, I'm going to let you guys put the right answer in. Okay, let's do another one, guys. What other questions do you have that you're having trouble with? 22? Okay, and we're looking on same worksheet? Okay, so 22, this is the integral of 6x over the square root of 3x squared plus 5 dx. All right, guys, this is a quotient rule problem. You can't do it unless you can get it out of this quotient rule form, okay? So to get it out, what I'm going to do is raise this to the 1/2 power. Okay, guys, anytime you see a square root, you need to change it to the 1/2 power, okay? So this is equal to this. Now, how can I get the denominator away? What do I do? Yeah, move it to the top, but I'm going to have to change this 1/2 power to negative. Good. Okay, and then this is a problem I can do. Again, most of the time, your u is in your parentheses. Okay, take the derivative of that, solve for dx. I'm going to replace two things, okay? I'm going to replace, what two things do I replace? My u and my dx. If I didn't circle it, I'm not going to replace it. So I'm going to copy everything else times u raised to the negative 1/2 times, and my dx is down here, du over 6x. Okay, and then I ask myself the question, do my x's cancel out? Yes, actually the 6's cancel out too. You guys good with that? It didn't have to cancel out, but that was kind of nice that they did. So what I have left is this right here. This should be an easy antiderivative or something on my formula sheet. Is this an easy antiderivative? Yeah, I'm going to add 1. Okay, I'm going to divide by this new exponent, which is 1/2. But when you divide by 1/2, guys, what are you multiplying by? 2. So this is 2u to the 1/2 plus Charlie. And that is a great answer. It is the wrong answer. Do you guys see that this is really 2 times the square root of u plus c? Isn't that what 1/2 is? And so then you can bring this in and say 3x squared plus 5 plus c, and that is a great answer. Okay? Yeah, go ahead, Chris. All right, guys, ask me another one. Which other one are you working on? Okay, which worksheet am I doing? The same one. Okay, so we're looking at the My Math Lab review, number 9. Okay, so this integral here, negative. Okay, also I want to tell you guys, it's nice if you use the same letter they have, like this is a letter S, but if you switch your letter to an X and you still get it right, I'm going to count it right. You guys good with that? So it's really nice if you use the same letter because it's easy for me to check with my answer key, but if you change it to S, then I'm okay with that too. Okay, so this problem, first of all, when you have a square root, guys, what do you always do first? Change it. Okay, so let me change this. -8 minus 3s raised to the 1/2 ds. Make sure you understand The square root is raised to the 1/2, not negative 1/2. I have so many students raise it to the negative 1/2. And I think it's because you want to change it a lot, okay? But you don't have to, you can't change it to something that it's not, okay? So then this is u equal to negative 8 minus 3s. You take the derivative of that. This is a du ds now instead of the du dx. So I think that derivative is just negative 3. Did you guys get that? Okay, so then I divide both sides, or I cross multiply basically is what I'm doing. Okay, I'm going to force this into a fraction on the left. It's a fraction on the right. When you cross multiply, then you solve for dx. Now, when I solve for dx, I'm going to replace two things. Now, remember what two things I replace? My u and my dx, or my ds, all right? If I didn't circle it, I'm not going to replace it. So I have the integral of u raised to the 1/2 times du raised to negative 3. Okay, this is really pretty cumbersome. If you get this, what would you do first? It's really cloudy over here, I feel like. I would take out, I would take out my negative 1/3. Do you see, guys, that that's a negative 1/3 and not a negative 3? Is everybody good with that? Okay, so then what I have here is u to the 1/2 du. And that really clears up my formula here, because then I ask myself, you know, is this something that is an easy antiderivative, or is it something on my formula sheet? And guys, you see it's an easy antiderivative. You want to add 1, divide by 3/2. That's your new exponent. But if you divide by 3/2, what are you really multiplying here, guys? 2/3, right? What's 2/3 times negative 1/3? Negative 2/9, right? U to the 3/2 plus Charlie, and that is a great answer. It is the wrong answer. You need to come back in and put in your u. Okay, and that is the right answer. All right? Okay, what other questions do you guys have? Ooh. Let's do some more, guys. Number 15? Okay, so same worksheet page or not? Okay, so look at number 15. Okay, so I have the integral of x cubed plus 2x times x4 plus 4x squared plus 7 raised to the 8 power dx. Okay, sorry, a little bit messy. 4x squared plus 7 raised to the 8 dx. All right, what I'm going to try to do here is FOIL, but this 8, FOIL is my plan. You guys get that? Okay, it's going to be really hard to FOIL this with the 8, okay? So what I'm going to do is just set this u equal to either this parentheses or this parentheses. Guys, which one am I going to set my u equal to? Yeah, the second one, because it has a higher power, right? This 4 power is higher than this 3 power. So u is equal to x to the 4 plus 4x squared plus 7. Then you take the derivative of this, and you get 4x cubed plus 8x plus 0. Then you solve for dx, and when you solve for dx, you force this over a 1. You cross multiply, and you'll get dx is equal to du of 4x cubed plus 8x. That's good so far. You're going to replace two things. What two things am I going to replace? My u and my dx. Okay, so I'm going to rewrite it. But if it has a u or a dx, I'm going to replace it. So this doesn't have a u or dx, so I'll put in x cubed plus 2x. This right here, x to the 4th, is really just u, right, guys? So this is times u. Oh, don't forget the 8. It's u raised to the 8. And then finally times your dx, and my dx is down here. So that's du over 4x cubed plus 8x. And I ask myself the question, using real algebra, not the fake stuff, do my x's cancel out? They do. Okay, let me rewrite the fraction, okay, because this is real algebra. Okay, here's your fraction. Does it have a common, does it have something in common I can cancel out? Look on the top, there's nothing to factor out, but what can I factor out on the bottom? Look at the bottom, what can I factor out? A 4. Okay, if you figure out, you factor out a 4, oh, even more than a 4, a 4x, but let's just factor out a 4 because that'll match it with the top. Okay, so I'm going to match it with the top. Just factor out a 4 only, guys. I mean, of course, you could factor out more, but then you'll have to factor out the top too. So if I just factor out a 4, here's the question. Do my x actually cancel out? using real algebra? Yes. And what do I have left? What do I have left, guys? 1/4. You guys good with that? So this cancels out to 1/4. So this becomes 1/4 integral u to the 8th du, u to the 8th du. I think that's right. And then you need to take the integral of this. I was actually going to be finished, but then I realized I didn't zip my pants. Did you guys see that? So even though I felt like I've done a lot of work, I actually never took the integral. So we need to zip your pants. Well, I'm not going to zip your pants. You zip them, okay? So this would be 1/4 times u to the 9 over 9 plus Charlie. And that is a great answer. It is a wrong answer. What do I do with this 1/4 times u to the 9? What is that? Very good. There is a 1/36 there, okay? So this is a great answer. It's still the wrong answer. Go back in and put in this giant u that you set up, okay? Over 36 plus Charlie. And that is the right answer. I don't know if you've noticed, but on your test, I'm not going to put any back substitution problem, okay? Everything else is fair game. Okay, but I took out the back substitution, so no back.
Miss Chang,
on your
sorry.
test. Yeah, go
Can
ahead.
you do number 9 on the review?
Yes. This is the same review that we're talking about?
The one you just posted today, like the one that you're doing today.
Okay, we just did number 9. You want to do it again?
I wasn't paying attention. Sorry, I was doing
okay, that's fine.
questions.
That's fine. Okay, so the integral of -8 minus 3s ds. All right. If you have a square root sign, you want to change that, okay, to raise to the 1/2. Be careful. Students would change it to -1/2. Make sure you change it to +1/2. All right. This right here tells you what your u is because it's in parentheses. Now your u is not always in parentheses, but a lot of times it is. If you take the derivative of this, you get -3. And so if you solve for dx, which here is ds, you get du over -3. Okay, remember I'm forcing this over one fraction on the left, one fraction on the right, and an equal sign in the middle. Okay, so I solve for ds. Then I'm going to replace two things. I'm going to replace my u. See if I can get that in a different color. My u and my ds. If I circled it, I'm going to replace it. If I didn't circle it, like the 1/2, I didn't circle it, I'm going to leave it alone. Okay, what do you see that you can take out of this?
Yeah.
Okay, so that makes my problem a lot simpler because right here, I need to have something that is either an easy antiderivative or something on my formula sheet. So it is an easy antiderivative, well, relatively easy anyway. I'm going to add 1, divide by this new exponent. This new exponent is 3/2. But if you divide by 3/2, you're really multiplying by 2/3. So it's -2 over 9 on the outside times u to the 3/2 plus Charlie. And that is a great answer. It is the wrong answer. Please make sure you come back and put in your u, which is -8 minus 3s over 3/2. And don't forget Charlie. Okay? What other questions do you guys have? Yeah. 18. So we're looking at 18 on the same worksheet. Guys, if I do a problem and it's a wrong problem, don't just let me go, okay? Like stop me. All right, so this is the integral of sine 4x minus 2 dx. All right. Always just make your, well, think about this. If I made my parentheses my u, is this on my formula sheet? Do I have a sine u, the integral of sine u on my formula sheet? Yes, so that is going to be my u. So u is equal to 4x minus 2. Now, just a caveat, like if I had x out here, I mean, that still is on my formula sheet, just FYI. You just look at the trig part of it, okay? All right, so then you'd say the derivative of this is 4. Okay, you solve for dx, and then you replace two things. You replace your u and you replace your dx. So this becomes the integral of sine u times du over 4. And this is really ugly. So what I do is, if there's a scalar, I try to pull it out. So what scalar is in here? 1/4. So if I pull that out, right here on the, what I have left, it should be one of two things. Either an easy antiderivative, or if it's a trig problem, it should be a trig problem that's on my formula sheet. Is this a trig problem on my formula sheet? Yes. What is the integral of sine u? So this is times negative cosine u plus Charlie. And negative cosine u times 1/4 is actually negative 1/4 cosine u plus Charlie. And that is a great answer. Okay, you do need to go back and get the right answer in. And your u was 4x minus 2. So just make sure you come back in and put in your u, and that is the right answer. What other questions are you guys working on that you need help with? Online, what are you guys working on that you need help with?
Go back to number 9 real quick, just check and see
Number
what you
9,
did.
okay.
It was a little quick, yeah.
This one?
Yeah.
Okay. 20? Okay. Okay, yeah, 20 is a great one. Actually, they're all great.
All right.
It's hard, yeah, it's hard to pick which one is my favorite. So I would pick number 20. Okay. And again, guys, I know it's a little difficult with the t's. If you want to change it to x's, I have no problem doing that, but it actually makes it a little harder for me to grade. All right, so right here, guys, I'm going to try, okay, well, first of all, are you guys okay if I get rid of all my denominators? Okay, so if I get rid of all my denominators, it'll be 7t to the negative 8 sine t to the negative 7 minus 1 dt. You have to do that to take the derivative anyway. So I'm thinking, let me just do that so it looks a little bit easier. Okay, that's the first thing I'm going to do. The second thing I'm going to do is make this my u. Okay, and I know I told you to look at the whole thing, but actually just look at your trig function, just the trig part. Do you have an integral of sine u on your formula sheet? Yes, okay, so don't worry about the x's on this side, but let's look at the trig part. I do have an integral of sine u, okay? So then let me just make this my u. Okay, the derivative of that, now it's, instead of du dx, it's going to be du dt, is going to be negative 7 t to the negative 6. You guys okay with that derivative? Okay, solve for dt. I used to solve for dx, but now I'm solving for dt. Okay, this really is one fraction on the left, one fraction on the right, and I'm forcing it into being able to cross multiply, and this is what I get for dt. So I'm going to replace two things. I'm going to replace my u and my dt. Negative, oh yeah, you're right, this is totally wrong. Sorry about that. This is not negative 6, this is negative 8. Thanks for pointing that out. Okay, all right, that's actually better because you can see it's going to match up here. All right, so this actually is going to be, if I didn't circle it, I'm not going to replace it. So I have 7t minus 8 sine of u times du over negative 7t minus 8. And then I ask myself the question, do my x's, do my t's cancel out using real algebra? Yes. So the 7's actually cancel out too. But guys, what do I have left? Do you see the scalar I have left? You see it? Be careful. There is a negative 1 left, okay? So make sure that you guys see the negative 1 if there is one left. And then is this an easy antiderivative, or if it's a trig problem, is it on my formula sheet? Is this trig problem on my formula sheet? Yes. What is the integral of sine u? Negative cosine u. So that's negative 1, be careful, times negative cosine u plus Charlie. And what's negative 1 times negative 1? Positive. So there is my answer. It's just the wrong answer. You need to come back and put in your u, and my u is a little bit awkward, but that's okay. It's this big thing right here, t negative 7 minus 1, and that is the right answer. And if you want to take some time to change this to 1 over t to the 7, more power to you, but you don't have to simplify in this class, so that's great the way it is. Okay, what other questions are you having trouble with? Number 8, same worksheet, Cassidy? Okay, so look at number 8. Okay, so given the following function of the object moving along a line, find the position function with the initial, okay, so PVA, okay, if I go this way, I'm taking the derivative. You guys okay with that? If I'm going this way, I'm going to take the integral. Okay, and what I'm given is VT is equal to 8t plus 5. And the question is, what is S equal to? Everybody good with that? So I'm moving from V to S. S is really which function? Sorry, guys. It's not exactly, yeah, it's really P, okay, because that's a position function. So I'm going from V to P. So guys, what operation am I going to have to do? Integral. How many times? Once, okay? So let's take the integral of both sides. The integral of V is P. Just FYI, maybe we should call this SVA because it's more often S, but I'm thinking position. So this is S of T plus C is equal to, okay, you just take the integral separately. The integral on this side is going to be 8T squared over 2, right? Plus 5T plus Charlie, all right? So I only need one Charlie. So what I have is S of T is equal to 4T squared plus 5T plus Charlie. Guys, I am looking for this on your answer. Okay, you should have this. But you need to solve for C. You can't solve for C unless you have an initial condition. Did they tell me something else? Yeah. Okay, this says when time is equal to 0, S isn't speed, guys. What's S? Position. Okay, so S is 0. So this is 0 equals 4, 0 squared plus 5 times 0 plus C. So what's my C equal to? Close. 0, right? So then all I do is come here, cross this out, and that's 0. And if you left your answer like this, I would count it right. I would just think you were lazy. But who cares what I think, right? So the right answer would be this right here. Okay. You want to see it again? 21. Well, Paula, do you need it? You do need 23? Oh, okay, well, let's do it. All right, so this one, I feel like you were the one who asked this one. Yeah, you weren't? No, I mean, even before, like we did it already. Oh, it's Ty, okay. So this problem here, that's okay. I would rewrite it, but this is the problem that I told you guys that, remember most of the time the parentheses is what your X is? What your U is, sorry. I would actually make the non-parentheses. I would actually make the tangent. But Ty did it with the secant, it was fine. But it was a little bit tougher with the secant. So I would make it the tangent. The derivative of tangent, remember, is secant squared U times the derivative of your U, which is 10. Yeah. It does work, but, oh, and you get stuck? And then what's your question? Yeah, I would just try tangent. It does work. It's just the sequence a little bit harder to do. And so then the dx is equal to du over 10. You can't multiply the 10 with the 10x because of families. You know how that is. Okay, so this will be 10 times secant squared 10x. Okay, that's what your dx is. You're going to substitute two things. You're going to substitute your dx and your tangent. So this becomes u times secant 10x quantity squared times du divided by 10 secant squared 10x. And using real algebra, not the fake stuff, do your secant x's actually cancel out? Is secant 10x squared the same as secant squared 10x? Yes, so I'm going to cancel those out to 1. And then what is the scalar that I have left? Do you see it? Yeah, not just 10, but do you see it's 1 over 10? Okay, so pull out that 1/10, and at this point, you should have an easy antiderivative, or if it's a trig formula, it should be a trig formula that's on your formula sheet. Guys, remember, you need to memorize all your trig formulas for your formula sheet, all right? So no notes, actually no notes, no calculators for this test, all right? Just you and your smart self, all right? So this, guys, is going to be u squared, I think 1/10 times whatever this integral is, which I think is u squared over 2 plus Charlie. That's a great answer. It's just not the right answer. This is really u squared over 20, right? So this is really 1 over 20 times u squared. Put in your u plus Charlie, and there's the right answer. And this one had 2 possible right answers that we could see. And anyway, it's possible we had more than just these 2. But these are the 2 ways I know how to do it. Okay, what other questions do you guys have? 4. Same worksheet, Olivia? Okay. Okay, so 4 is the integral of -4 secant x tangent x plus 5 secant squared x dx. All right, when I look at this problem, do you feel it welling up inside of you? Do you feel it? If you think you get to do one problem, but look at this. Oh boy, you get to do 2 because there's 2 different terms with a plus sign in between. So I'm going to do this problem here. And go ahead and add the dx now. Okay, separate from this problem here. They're like 2 separate problems. Okay, and look at this problem here. It's nice that the x is just your x and not your 10x. Like if this had been 10x, you'd have to do u substitution. But do you see that this is just x? So you don't have to do u substitution if this is on your formula sheet. So think about this. Do you see the -4 is a scalar? So if I pull out the -4, what's the integral of secant x tangent x? Is that on my formula sheet? Right? The u's are all x's now. So what is that? Make sure you look at your formula sheet. Okay, you guys tell me what that is. I'm going to let it go. And then on this side, your 5 you can pull out. Okay, so this is just added with whatever this answer is. This is 5 times the integral of secant squared x dx. But is this on my formula sheet? Because it's just an x, right? If it were a 10x, you'd have to do u substitution. This is just an x. So what's the integral of secant squared x? Do you guys know what that is? Okay, if someone doesn't tell me, I'm just going to leave a blank. And then don't forget Charlie. And I don't need 2 Charlies, right? I just need 1. Okay. Make sure you guys are really comfortable with your integrals and your derivatives. Okay, you got to go fast on that. All right. I've told you before, I'm not doing formula quizzes this year, but that actually makes you worse at calculus because you're not as confident on your formulas. So please go sit down in a closet tonight and rewrite all your formula sheet and make sure you know the answers to all of those integrals and derivatives. Okay. What other problem are you working on? Number 5, cinco? Okay. Did that mess you up like an Asian speaking Spanish? No? Okay. I can't believe you answered that question, Gabby. Okay, so here we go. Okay. I'm going to change this to 6x. Are you guys okay with that? Just because it's the same thing, right? So we could follow it. Okay. Right here, if I make this my u and this my u, is this something on my formula sheet? Do I have something on my formula sheet that's secant u tangent u? Do I? Do I? I think I do, right? So if I do, then set your u equal to 6x, take the derivative of that, solve for dx. Okay, then you're going to substitute 2 things. Okay, actually, since I have both of them on my formula sheet, this is one of those exceptions. You usually cannot have 2 u's, but this is on my formula sheet, so I do have 2 u's. And this is du over 6, secant u tangent u du over 6. Pull out the scalar. Do you see the scalar in this problem? And at this point, this should be something that's an easy antiderivative, or if it's a trig rule, it should be on my formula sheet. Okay, so what is the integral of secant u tangent u? Isn't that just secant u? Okay, so there's my answer, but don't forget to come back and put in your u, and there's your final answer. On this problem, I would make my u equal to 10. No, I wouldn't. If I make my u equal to 10x, I look at this and I say, just look at the trig part of this. Do I have a formula that's tan secant squared? The integral of tan secant squared. I actually don't. Okay, I have a secant squared formula. I don't even think I have, and I have integration of tan formula, which I don't think you've learned yet. And I think that's it. So I don't have a tan secant squared. So that's actually not going to be my u. Okay, so what do I do with the u here? Well, what I'm going to do is come through here. Oh, okay. Remember I told you about the parentheses that the u is 95% of the time the parentheses, well, it's not on this problem. Okay, if you make your u equal to secant, oh, that'll work actually too. Oh, both ways will work. Okay, what did you make your u equal to? Whoever, Chris?
No, it was me.
Oh, Ty, which, it'll work both ways.
Secant.
Okay, it'll work. It doesn't always work for both ways, but yeah, it'll work for this way. So if your u is equal to secant 10x, so, but do you see you only made one of your u's? You can't make this a u. Like this can't be u squared. It's going to have to be this. Secant 10x times secant 10x. And only this one will be your u. That's how you have to make this one to work. Okay, so your du dx is going to be secant x tangent x times 10, right? Times the derivative of your u. So the dx is going to be equal to du over 10 secant 10x tangent 10x. Okay, you with me so far? This is a little bit confusing because you actually can only make this your u. You can't make both your u's. You can't have two u's, okay? And the reason is because it doesn't sit in the formula like that. So when I replace two things. I replace my u and I replace my dx. So I get 10 tangent of 10x, I'm just copying, secant 10x times my u and times my dx. Okay, right? This is my dx down here. So then I ask myself the question, do my x's cancel out? Yes. The tan cancels out with the tan. I think this is tan. It's so messy. And then the secant cancels out the secant, and that cancels to 1. And so what I have left is a scalar that's 1/10. Do you see that? So I'm going to pull out the scalar. Guys, you can pull out scalars, but you can't pull out letters. So you cannot pull out the u outside the integral sign. You can't pull out x's outside the integral sign, but you can pull out any number that's being multiplied by everything. Okay, so this answer is 1/10 times u squared over 2 plus Charlie. And that is a great answer. Okay, yeah, you do need to simplify. So 10 times 2 is actually 20. And you do need to put in your u. So that's secant 10x squared plus Charlie. And if you got that answer, I may not have put that on the answer, and I'm sorry. Okay, but that's another answer you could have. So some of your answers, guys, you could have two possible answers, or more actually, with integration. And this is another answer you could have for 23 that probably wasn't on the answer sheet. I would think most of you guys would have set u equal to tangent x. Did most of you do that? Because that one's a little bit easier to do, okay? If you had set your u equal to tangent 10x, that one works out a little bit nicer, okay? 24.